All right, cool. So it is just about Berkeley time. So I'm going to move things over. Let's see. Hide everything. Let's see. All right. So let's get ready with this. Come on, PowerPoint. And slides up. All right, cool. Desktop 1. I think everyone can see that. And then I will go. Let's see, actually, what should I do? One sec. All right, just so the Zoom recordings don't run. Cool, so sorry about the issue with Monday's lecture. Hopefully you get a chance to watch it. If you haven't watched it before today, that's perfectly fine. Today's lecture won't really rely on anything. Lab, the trees content will be useful for lab, so if you get a chance to skim it, at least beforehand, or to read through some of the slides and questions, that will be good for lab. But most of your TAs will also be going over tree stuff in lab. So don't worry about if you haven't gotten the full lecture before starting lab, but it would be good to review at least some of it. Related to needing to re-record lecture, I don't have any self-check questions for this lecture up right now, but I will post them up tomorrow. But again, it'll just be for quick multiple choice questions, so hopefully them being a day late is not too big of of a deal. But those are up there. And then just as a reminder for self-check questions, they total up 20 points throughout the semester, which is 5% of your grade. Not a ton, but 5% certainly can make a difference if you're on the boundary, and hopefully they're just useful practice. So if you're missing any, or if you've submitted them and gotten them wrong, you can resubmit them for credit. We've said this a few times, but just making sure that everyone knows about that. Otherwise, Ant's checkpoint is due Friday night. It's parts 1 and 2 of the Ants project, which despite there being 4 parts, it's definitely not half the work. So don't, when you balance your time, just keep that in mind. In terms of the fact that parts 1 and 2 are meant to be easier, but we do want you to get started for that kind of stuff. Next week, we will start doing SQL. So on Monday, we'll talk a little bit about databases, why we're going to work with SQL, what some of the big ideas there are in terms of programming. And yeah, lab, in terms of the next couple content, lab should be out later today for the trees lab. And then I also got a question in the chat about lecture drops. Yeah, so there are, we will drop 3 self-checks because I believe we'll end up with 23 lecture quizzes, and you need to get 20 points. So essentially 3 of them will be dropped if you forget to do them. There will be, so Thanksgiving week, there will be no, let's see, let me actually, I believe there will be a couple shorter assignments, but things will be moved around. There will be no labs in class, and they will be, the due dates are shifted, so nothing will be due during the break. But I think, sorry, so the lab that comes out today, because it'll be due a week, will be due the following Sunday instead of the following Friday. So you'll have a couple extra days, so it's not due on a school holiday. And then there won't be a new lab posted next week, but there will be one the last week of class. So if you attend lab this week, you'll have about 7 to 10, or probably like 10 to 11 days, depending on when your lab date is or when you start to do it. And then there will be, after Thanksgiving break, a new lab the last week of class. And that'll be it. So there'll basically be 2 more labs for the semester, this week's and the one after. There will be a small homework that is out this week that will be due at the end of next week, but there won't be a new homework assignment posted, is the way that will work. But yeah, next week, because of the holiday, will be lighter. We'll still have a recorded video up Monday. Office hours Monday and Tuesday will also happen, but nothing Wednesday, Thursday, or Friday. So just keep that in mind if you do have questions. We will be monitoring Ed, but not as diligently, especially Thursday and Friday. So, if you have something urgent, just try and highlight that. But hopefully, during the break, no one has anything urgent, because you should all be taking the break as well. So before we get into the iterators and generators portion of today, just a quick news story, which is interesting, if not a little bit concerning. The University of Michigan has been conducting studies about internet censorship, and they found that through their automated monitoring techniques, censorship has been increasing in places that we consider to be democracies. And so they've been doing this over the past 20 months. And, in this case, it's more just informative in terms of understanding, what's going out there for censorship. But, in terms of interest in topics, even though many of you are data science majors, the ethical implications of computing and the internet as a whole are certainly a wide-ranging topic, and there's a lot to explore there. So, some of the human context and ethics courses get into some of this. If you like this kind of news stories or thinking about censorship and the social implications of computing, there's again CS 195, which is, despite being a CS upper division course, is accessible even if you have just a small amount of sort of technical understanding. So everything that you've done in CS8, you don't need to know how to program to take it, but just that context is helpful for the course. So I thought that was interesting that I came across. The full link is there. But with that, today what we'll do is we're going to talk about iterators and generators in Python. And then we're going to go through a notebook and explore some of the stuff. So before we get into it, just a word of warning. Feel free to post questions in the chat, and I will, or raise your hand, and I will happily answer those as I see them and as I can get to them. But there are a lot of terms in this lecture that are pretty similar. Notably, we have things like sequences, iterables, iterators, generators. So don't feel too bad if you start mixing things up. It takes time to get used to these things, and I will frequently find myself, if I haven't done this super recently, reviewing the Python documentation for a term. And the point is not necessarily to understand every single minor detail, but the concepts of what we do, what we're trying to do with functions that can generate data sort of on demand. And the other meta goal of today's topic is to pull the curtain back a little bit on tools like the for loop, map, filter, the zip method. These all do very interesting things in Python, and they're quite a bit more complicated sort of than they initially seem. And so one of the things is, after today's lecture, you'll have the ability to, in some sense, go through and implement a method that works like map, that only generates or computes the data when it's required to. And if you continue on, this is a really useful technique for dealing with large amounts of data. So that's one thing there. But despite the fact that we're learning Python-specific terms and implementations, these ideas exist in many, many programming languages. So they will, they will look a little bit different in other environments, but they are all sort of, different flavors of the same kind of idea. So the two biggest words that will be useful are iterable and iterator. So an iterable in Python is an object that is capable of, when we say yielding its members one at a time, it is something that you can think of as us being able to say for item in a list, for letter in a string, for item in a tuple. We haven't built our own iterators yet, but what we'll talk about is how you can build them yourselves. But they are functions that basically we can put into or objects that we can put into a for loop, essentially. And any of those things that we can drop into a for loop are something that are kinds of iterables. Python has a specific kind of object called an iterator, which is, you can think of it as an instance of an iterable object. So in the same way that an object is an instance of a particular class, an iterator is a kind of instance of an iterable type object. And importantly, Python has this idea about sequences that we're not going to get into too much, but sequences of Python are things that are ordered and that we can index, so using square brackets. And so far in CS88, and for, frankly, a lot of programming, you will treat iterables in Python as if they're sequences, things that have an implicit order to them. So strings or characters in a string have an order. Otherwise, our words wouldn't make sense if we shuffle things around. Actually, you can read the studies. Sometimes they might make sense if we shuffle the letters around, but that's not really the point. But lists certainly have an order. Dictionaries, notably, don't have an order, so they're technically not sequences, but they are iterable objects because we can iterate over them. And there's a link to a particularly good blog post here that just lays out some of this, as well as some of the next topics that we'll be going over in this lecture. So if you want another form or phrasing of any of this, feel free to check that out. So in Python as well, we have things like lists, strings, tuples. There's a whole bunch of functions that also return iterable data that we've used. There are things like map, filter, range, zip. And these are not sequences because we can't necessarily index them. Range, you technically might be able to. It depends on the exact version of Python. But basically, we're going to say, these aren't sequences, but they are things that we iterate over them. And because they're iterables, this is why when we use them, we needed to call list or tuple to see the entire result of a map. And so in a few minutes, when we open up a notebook, we'll play with that and just kind of remind ourselves of what was going on with those. But there's quite a few of these in Python, but there are basically, you'll have the ability to implement as many of them as you want. And so the question becomes, how could I implement a function in Python that has this property of map or a filter or range that returns data only when asked of it? And there's two primary things that Python has, and these are iterators and generators. And we're going to start with generators. They're possibly a little less common, but they're a little bit simpler to build. And the way that generators work is they return this yield keyword. And so instead of saying, let's look at this function here, when we want to make squares, so if we wanted to say, for I in range 10, compute all the squares from 0 to n, so 0, 1, 2 squared, 4, 9, 16, and so on. We could write a map. We could do anything like this, but we could write this function called a generator, which uses this special keyword called yield. And yield is really cool because it is sort of like a special return statement. It says, when I do this for loop, if I put return, so let's just think about this. If I said squares n, and I said for I in range 10, I is going to start off with 0, 1, 2, 3, and so on, right? It's just going to be the values of range. If right here I just said return, our for loop would exit after one iteration. It would say I is 0, we return 0 times 0, not very useful. But what yield does is it creates a special environment in Python that whatever our function was called as, it returns that value without returning or without ending the function as a whole necessarily. So the next time the function is called, yield picks up the state where it's left off and continues on. And so this will make the most sense in just a second when we get into a notebook. But before we do that, it's just worth pointing out with yield that we can nest it. We can put this in for loops. We can put this in while loops, and so on. And so now the meat of this is going to be working with a notebook. Before we do that, with the caveat that this all makes a little more sense, I think, when we've played with code, I'm going to take a second. Any questions on this idea of creating a function that does something sort of in the background or lazily or on demand? Any kind of questions so far? All right. If no questions, then we will continue on. So this notebook, which we'll have available afterwards, this just starts off, let's make it just a little bit larger for the recording. But this starts off with just a review of some common sequences. So we have things like lists. We can get the length. We can index them. We can always use a string as a sequence as well. So we have strings that work like lists. We could have used tuples, but we can also make our own sort of sequences that we iterate over something. So, whoops. So S was the list of numbers 1 through 4, or yeah, 1, 2, 3, and 4. So if we say for X and S, Python is going to, for each iteration of the for loop, figure out what the next value in our sequence S is. So we're going to start off with S0, S1, S2, S3, and so on. And it doesn't matter what kind of for loop we use or the structure, but that's what Python's going to do for us. If we wanted to, we could iterate over a while loop by mutating S itself. We could use an index, but we'd have to modify or keep track of that value ourselves. And so the goal again is going to be to build some of this up. But we have range if we want. And for now, we'll just skip through a few of, we won't go through every single example here, but it's worth pointing out again that remember when we see something like this map object here, that Python is giving us that object that we're now telling you is a special thing that is an iterator. And so what we're going to do in a few minutes is to build our own iterators and to figure out what we can do to tell Python that something is an iterator. One thing that will be useful is this function any, just for a couple of the examples. Any, we have an implementation here with any1, but if there is a list and any single one of the items is true, the list itself, or the result of the function, will report true. There are a few false values in Python, which are 0, false. The empty list and the empty string are sort of the main ones. But basically, if anything in this list were to be true, I could say true. Why did I not get? Oh, because I put it in the wrong spot because it takes in a list. So if any single one item of a list is true, regardless of if all the others are false, this will be true. It kind of works like OR. So if A or B, if one of A or B is true, the result of the expression is again true. And so there's a built-in function any, but here are two versions that you can think of implementing on your own. So again, we're just going to scroll through this. But what we want to do is to work on building up to this question of what happens when we have large amounts of data. So, and more importantly, just how can we build things that Python has. So one example that we're going to work on is a fairly common computer science question. Is a particular number prime? So we have this function called prime, and we can just evaluate it. Whoops, not print. Prime of, let's say 5, or well, let's say 5 first. So 5 is a prime number. That's good. If we said 4, 4 is false. And this works by saying if any factor of I, or I guess n, so for I in range n, so if any factor of our number n divides evenly, then the number is not prime. And n greater than 1 just protects from a couple cases like 1 being evenly divisible, and so on. But so this value, or this function, will return true for numbers that are prime and false for things that are not. And what we can do, our zip function, if you remember, just groups items together, but we can use ranges, we can map things over a list, and this just tells us for a bunch of items or a bunch of numbers, are they prime or not? But the question is, in Python, what happens when we want to do something like a really, really large computation? And in this case, we'll notice that when we said map of prime, this happened almost instantly. And despite the fact that computers are fast, they're not that fast. And so what Python is doing here is it's waiting until we actually try and call a value of map or turn it into a list to compute those results. And so there's just a few more examples of playing with this that we're going to skip through just in case. But you can see that with things like zip, you can just keep iterating through them. So our first foray into trying this is to just look at building our own function that squares these numbers. So you could write for I in range n, scoring a value, and so on. But what we're going to do now is introduce this keyword. So for I in range n, yield I squared. And so we'll notice that when we call this, we get squares of 5 returns something new. It returns a generator object, not the result of squares, not the result of a list. It is this special generator object. And if we want to, like map, we can call list, and this now works like a map function. So if we call list of squares of 5, we're doing the exact same thing as list of map of something else. And so yield is going to be the first foray into building something lazily. Python internally uses this function called next to compute the next value of a generator and also of an iterator. So if we say next of squares of 5, we get our first value. And interestingly, every time we call squares of 5, because it is a new generator object, we get we start from 0 again. So we could, this would be a highly inefficient way to get items. Can I not call? Oh, no. Oh, I can't call next of an int. Duh. That's not what I wanted to do. Okay, let's do this. Let's call this of sequence, or let's just actually call it squares, because that's a little more clear. So we have squares, which are a generator, and we can call next. We get 0. And if I make a new cell, just so this is a little more clear, we can again call next of our result. Oh, I hit it twice. So let's try this again. Let's make a new sequence of squares of 5. Our first time we get 0. Our second time we get 1. And so what Python is giving us is a tool to generate, to create a generator, which until we call this special function next, until we say turn this thing into a list of values, it doesn't make a computation. And so this is our first way of creating something that evaluates lazily, that returns data only on demand in Python. And then we'll talk in a few minutes about building this into our own classes. So I'm going to stop there. There's kind of a lot going on here. So questions, comments. No questions. So if I were to write next of, oh gosh, I ran this one too many times. Let's see. So let's reset this. So we start 0, we start 1. When I run this cell, what should I get back from the value of next? So I'm right here about to run this. What should my next, when I call the next square, what should I get back? Got to vote for 4. Votes for anything else. Cool. Yep. So 4 is correct. We should get 4 back. Now let's see what happens. We'll just see if we can, we'll do this one more time. Whoops, I ran 9. So that was 3 squared. Next of square. So this should be 4 squared. And then, darn it, I was going to ask what we would expect to happen if I ran next 5 times, but it's way too easy to enter in a notebook. So this is one of those things that Python will do, is that if we try and call next too many times, we get this error telling us that we need to stop iteration. And this is basically just saying we've reached the end of our sequence or of our generator object, or also an iterator. So you'll note that by it saying stop iteration, generators are objects as well that we can iterate over. We can also say something, for number in square, let's see, squares of 5. Well, yeah, let's just do 5. We can print our number, and we get back these squares 0 through 16. So what's cool about the for loop is when the for loop itself knows that when we get a stop iteration error, it says, okay, I've reached the end of my for loop. And that it becomes exactly how Python in its own for loop handles knowing when you've reached the end of something, is whatever object we are iterating over at some point says there's a stop iteration error, and that's how we've gotten to the end. The actual for loop implementation is slightly more complicated, but with this, with knowing how to make a generator, with understanding lambdas, and a little bit with understanding how you can raise an error, and then we haven't talked about this yet this semester. Normally we might, but in CS88, we will sometimes talk about exceptions, so you can catch an exception so that it doesn't sort of blow up your program. But with just a little bit of Python syntax, you can actually re-implement your own for loop in Python. Cool. So that's a little bit about generators. Any questions on this example or yield or anything like that? No? All right. So again, I went through a print statement, but anything that we want to do with a set of with our existing tools map with for loops, we can also do. So if in this case, if we wanted to map square root over a list of squares, just to prove that we can get the values back, we could do that. Now there is one thing about generators which is worth knowing, and this is why in a few moments iterators will become useful. When we want to say what is the 6th or 7th or 100th value in my sequence, we need to support some additional tools to allow that to work. There's a few of these that we'll talk about. We've seen get item, that would also work, but there are some additional tools and iterators that we can use as well. So that's going to be what we build up to. But for now, we can talk through one more example. So we have our prime function, and we want to know what are some of our prime numbers, and we can do this by yielding each prime. And so if we just asked for our first 5 primes, this would be a little bit more clear if we printed the number, but we can see that we have 2 and 3 are prime based on their positions in a list. But we can also build a little bit simpler of a generator that just generates prime numbers for us. So let's actually just do this before we get into a for loop, which let's say if we said p equals primes. So we have this generator, and we can, if we just evaluate that, we can call next of p, and we get 2. And I'm just going to, instead of creating a new cell, I'm just going to rerun this. We get 3, we get 5, 7, 11, 13. And so this is a pretty common pattern for something like a generator, where each time we call it, we keep getting the next value in our sequence. And because we used a while loop, this will keep checking if go through its own value starting from 2, and only when we find the next number that is prime will it return. So here's a good question, which is, for how many times can I keep just evaluating this next of p? Should I keep doing this until the end of lecture? Well, I should probably not keep doing it, but could I keep doing this until the end of lecture? Yes, I could. And this is one of the cool things about generators. Something that you really have to be careful with, but generators are a really useful way to represent infinite sequences of data. And that is a tool that we'll find that you may find useful in other languages, especially when we're dealing with something that is naturally infinite, like a series of prime numbers. So that's a little bit about some prime numbers. We have this first function, which will give us the first, whatever many items we have in there that we can do. And then we have a couple more examples here that I'm going to skip over for now. But it's also worth pointing out that, like our slide said, we can nest things. So if I wanted to yield each pair of items, I could nest my for loops. So this, if I have a list of 3 items, I should get back 9 items. So 3 times 3 of each different kind of grouping of items together. So no matter where we put a yield in our generator, we have the ability to go through and work on and yield some data. And if we wanted to, we could see, that's a similar way of just writing list comprehensions in with nested for loops. So any last questions on this idea of a generator? So if we want to have a little bit more control, Python gives us the idea of an iterator. And turning, sort of giving us a bit more control over ways that we create data. And so if we want to make our own objects, things that can be iterables, so one particular exercise, I don't believe we're asking you this this semester, but it might appear on a homework, would be something like, can we turn our linked list class into an iterator such that I could say for item in link and go through item by item of our linked list class. That is a function that right now we can't do with our current link class that we've provided. But after today, you'll be more than capable of writing. And the way that this works in Python is, like many things in object-oriented programming, yet another magic method. And the particular one today is the special method called next. And we can think of next as kind of like yield, but for a class. And we have a particular method called iter, which gives us the iterator object for any class. So the way in Python this works, next is the more interesting of the two, but both are very useful. Is if we want to make our own objects iterables, then we implement these two methods, iter and next. The iter method just returns an object that implements the next method. So in most of our classes, the types of things that you would be working on in CS88, you can simply just return self. But in many programs, your iter method might be a little bit more complicated, but we won't really get into that. But just calling out there that technically in Python, there are two things that you need for your own objects to become iterables. This iter method and this next method. And the next method is the more interesting method. So it returns the next item in our sequence of iteration, which means it gets to keep track of what the list, or not necessarily list, but what element we are currently on, what should be next, and when we are done, the next method raises the stop iteration exception. In a similar way that in the homework for this week, you are supposed to raise an index error when you passed the end of a linked list for insertion. Our next method raises stop iteration to say there's nothing else left in our sequence. And because we get to define this method, we can define whatever kinds of iteration we want. We could define a list that iterates over only the even items in our list. We could define a particular way of if you had a chance to look over anything related to the trees lecture yet, you could iterate over a tree in a particular fashion, including randomly. Would not be very effective, but you could. And so depending on your class, this will be a little bit more useful. And it's also worth calling out that Python gives us another tool called getItem that we used in the first linked list lecture to index a particular linked list. And if we implement the getItem method, Python will also internally figure out how to build an iterator. But for today, we're going to focus on the next method. And so for now, we'll hop back over to the notebook. And then this is probably after a couple of these examples where we'll leave it for today. So did I not define all squares earlier? I guess I didn't. Let's see. What did I skip over? Oh, that's my bad. Okay, cool. All right. So now we've got this all squares thing. It's a generator. I've gone through this a little bit, but we can keep calling next to get through our squares. And you'll notice in a way that the global next method is really just an alias for our __ next method. So when we use yield, what Python does is it internally creates a generator object that implements this iterator protocol. And so we could just keep calling next until we get to the if there is an end, in which case our all squares, I believe, is an infinite sequence. So in Python, there are a couple things that we can do before we sort of add these to our own class. So we mentioned that there is an iter method that returns an iterator object. And in a lot of cases, you don't need to do this yourself, because a for loop will do something like return the list iterator for you. So I could say next of x, and I could keep iterating through our list until we get to the end. And if let's see, let me make this a new iterator just so I don't have an error. I could again call next directly. What I can't do with an iterator though is I cannot index an iterator on its own. So that is where we would need a getItem method. But what's worth mentioning here is that, so x is an iterator. What did we call? We did not save our list, so let's actually just do this. Let's call this n for just numbers and remove that. So n is itself a list. What I cannot do on our own is I cannot directly call next on a list. So a list is a kind of iterable object because it has an iter method, but I cannot directly call next in this case because a list does not implement the next method. And we could see this by trying to access next on a list, and it says it has no attribute. So sometimes in Python, this is where we get to the idea that an iterator, or excuse me, the iter method returns the iterator of that object. And And lists are one of the cases that do that, but technically speaking, in your own objects or classes, you don't need to. So again, with all squares, we can keep calling next forever and ever. For a string of s, we can also build an iterator. Strings work in a similar way to lists, where if we were to do this manually, we need to call iter of s so that we can call s, or excuse me, so that we can call next. And again, we can keep calling next until we get to our stop iteration error. And this works pretty much the same way, or another example of the same things that we've gone over. The last example here is thinking about what if we wanted to implement range ourselves. So naturally, if I said, we want you to build a range function let's just call this slow range. And we can call this n. And we'll say, we'll just go again from 0 to n. So, and we'll have result is equal to a list, while I is less than n. We can say result dot append of I plus equals 1, and at the end we can return result. And we can call this, let's see, slow range of, let's just do 10. So, if I asked you to build range, and I told you couldn't use a for loop or the existing range function, this might be a simple approach. Just while we're less than a number, create a list and append it to it. But what we can notice here is that we're doing this work, again, of building the list on demand. And what we'd like to do is to support a range class which computes the next value only as it needs to. And so we have, instead of just a simple function, we do the same kinds of things. We're going to track I, so our current position was 0, and we're going to give ourselves the ability to get the next method until I reaches the value of n. And so this is what my range looks like. We can call my range a 5, and we can still say x for x in my range of 5. We can do all sorts of other things. We can call list, this should work, of my range of 5. We can get back the list as well in the same way that we would with map. We can also do the cool thing of calling my range of some ridiculous number, and we just get our own custom range object back. And so this is really all you need to implement your own iterators in Python. And if we want to, we can verify that the next method of a range works correctly. So if I said my range of 2, we go 0, we call 1, and what did we say in our implementation? If I is less than n, we return that value. Otherwise, we raise our stop iteration error, and what gets returned is this error message. So that is next and range. And there are a couple more examples in this notebook of how we can use getItem. GetItem essentially does the same thing. And the final thing is, if you're ever curious in Python, you can ask Python if an instance of an object is either an iterable or a sequence or even a generator. So there's a little bit in here if you'd like to continue exploring, but none of this stuff that we didn't get to are things that we would quiz you on, but it may be interesting if you are if you're just interested in exploring. But the main thing is yield for generators, the next method to build your own iterators, And all of these things allow us to do a bunch of lazy loading or lazy computations of our data. So that is basically it, but I will hang around if there are any questions. So thanks for coming. I will see you in 2 weeks. Will be our last lecture. And then there will be 2 more recorded videos for the next 2 weeks.